Welcome to section 6.4, equations with rational expressions and graphs. Okay, so note, what do we need to be aware of when solving equations with rational expressions? And here's a hint, the variable is in the denominator. Okay, so for example, if I had an equation, let's say, once again we're talking about rational equations, so you're going to have fractions in them. If I had an equation with fractions, what is something that my variable could not equal? Well, with a variable in the bottom, what can x not equal? X can never equal 0, right? So we have to be careful. We have to find the values that would not work. And sometimes what will happen is your only solution might make your denominator 0. Or for example, if my denominator was x minus 2, and one of my solutions was that x equals 2, it may not make this denominator equal 0, but it would make this one equal 0. So sometimes if our solution makes our denominator 0, we're going to have to say no solution. Extraneous. You could say makes denominator undefined, which means you have 0 in the denominator, or makes the denominator 0. Different ways to answer. So state no solution and then state your reason if your answer makes your denominator equal to 0. So that's something to be aware of. Let's take a look at example 1. Give the domain of the variable in each equation. Okay, so all we're going to do is give the domain. And basically, once again, that means the values that we're allowed to use. So let's take a look at where our variable is, down here and down here. So I'm going to set each one to 0 and see what the problem number is. I don't need to set this to 0 because there's no variable there. So solving for 0, we get x equals 0 and x equals 0 for both of them. So the only number that we can't have in our domain would be 0. So the domain of our number, the domain of x, would just be negative infinity to 0, but we have to take out 0 because it causes the problem right here, and 0 to infinity. Let's take a look at the next one. Okay, so we have our variable in all three denominators this time. So once again, we have to set it up and figure out which values make my denominator 0. We can't have those because that's undefined. Okay, well, solving the first two is pretty simple. Add the 7 to both sides. X equals 7. Solving the next one. Negative 7. And solving the last one, a little complicated, but notice, this is the difference of two squares because 49 is a perfect square. So this factors into x minus 7 times x plus 7. And we have to set each of these individually to factors. Got a bunch of work going on here. But solving these, we're actually going to end up with the same answers that we had in the other two. We can't have positive 7 or negative 7. Oops, that should have been a plus sign. So we found the two that we cannot have. Go ahead and graph those. Negative 7 and 7. So those are the two problem numbers. That would make my denominator 0. Any other number could be a possible solution. It's not saying that all the other numbers are the solutions. It's just saying any other number would be okay if it was a solution. So the domain for x or of x would be negative infinity to negative 7 union negative 7. Oop, gonna run out of room here. Let me rewrite this. So the domain of x, we're just taking out the 7 and negative 7. Negative infinity to negative 7. Union 7 to infinity. So once again, we have 1, 2, 3. So 1, 2, 3 different intervals we're looking at. So now let's take a look at example 2. Solve the following rational equation. Okay, so we have to solve it. And we have to be aware of which numbers could cause a problem. So there's two different ways to do it. You could first determine the domain for your number and then solve, or you could solve and then determine the domain. I'm going to go ahead and solve and then determine the domain. So, how would you go about solving this? Well, there are a bunch of fractions, and I don't really like the fractions. And lucky for us, this is an equation, which means I can use the multiplication property of equality. I can multiply both sides by the same number, and when I do that, I can be sneaky, and I can get rid of the denominators. How? Well, let's create a common denominator. In order to do that, though, all the denominators need to be factored. These two are already factored, but this one is not. Let's go ahead and factor it. That's the difference of squares. Not bad. And now let's create our common denominator. Well, the first one, x minus 3, I'll go ahead and plug that in. And then the second one, I need an x plus 3, so let's go ahead and plug that in. Okay, so these two are okay. And last one, do I have an x minus 3 in here? I do. Do I have an x plus 3 in here? I do. Okay, so now we've created the common denominator, and now we're going to multiply that to both sides in order to cancel the fractions. And you can only cancel the fractions when you're working with an equation, so please remember that. You can only cancel when you're working with an equation. That is often where students get mixed up, so make sure to take note of that. Alright, so I'm going to go ahead and write this out. You don't have to write out this step usually, but I'll go ahead and do this. So I have x minus 3 distributed in x plus 3. Sorry for the dog sound in the back. X minus 3, x plus 3 equals 12 over x minus 3, x plus 3, x minus 3, x plus 3. Alright, so we distributed it all out. Remember, our goal is to cancel the fractions, which we can do because it's an equation. Alright, so when we do that, those cancel, 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 cancel. Awesome. So we don't have any more fractions, I think. What are we left with? We're left with 2 times x plus 3 minus 3 times x plus 3 equals 12. Let me highlight the items that were left over. All right. Awesome. Look, we got rid of those fractions. So now let's just go ahead and distribute out and continue solving. It's a nice linear equation. So we get 2x plus 6 minus 3x minus 9 equals 12. Oh, sorry, that should be a negative right there. Let me go ahead and fix that. Just waiting for my pen to catch up. Okay, so it should be negative, which means this should be positive 9. Okay, so continuing solving, combining like terms, and we'll get negative x. Let's see, so plus 15 equals 12. I'll go ahead and get x by itself, so minus 15 from both sides. Then we get negative x equals negative 3. Dividing both sides by negative 1, and x equals 3. Okay, so we found out that x equals 3. Are we done? Careful, remember, we have to make sure that my variable that I found doesn't make my denominator equal to 0. So what numbers are not allowed? Well, I'm not going to require you to state the domain, but what I would like you to do is to check your answer. Okay, so I'm going to look for checking your answer. So go ahead, rewrite your original equation, and then you're going to plug in your solution. And if it makes any of your denominators 0, then you know that there's going to be no solution. Okay, so let's go ahead and plug in our answer for our variable. Let me go ahead and set that up. So we had 3, so 3, 3, 3. And we plug it in, we get 2 over 3 minus 3, ooh, which is 0. Okay, already that first one we have a 0. Now this is 6. That's okay, but because we have 0 on both of them, or at least on 2, because this is going to equal 0, If you have 0 on just one, even if the other ones are okay, it's still undefined because it makes one of the denominators 0. So because of that, no solution. So for these rational equations, once again, for the solving, after you found your answer, you need to show the work for the checking and then state your answer. If you have a solution, continue to box your solution. If you don't have a solution, you're going to write no solution and cross out your answer because it's not a solution. All right, let's take a look at example 3. Solve the following rational equation. This is a big one. And how do we solve these? Well, remember, I don't really like fractions, so if we can get rid of the fractions by using a common denominator, that would be awesome. How do we do that, though? Well, first, let's factor these and see if we can create a common factor. So this would be p plus 2, p minus 1. Ooh, this is the difference of squares, so that's p minus 1, p plus 1. And the last one, how does that factor? That's going to be 2 times, gotta bring down that 2, p plus 2, p plus 1. Yeah, alright, so what would my common denominator be? Well, I just go ahead and throw the first one in as usual. So I know this one's good. How about this one? Do I have all of those values in here? No, I'm missing the p plus 1, so I gotta put that in. And I'm done. How about this one? Do I have all of those up here? Well, the only one I'm missing is the 2, so I have to add in that 2. And now I've created my common denominator, which is actually kind of huge. But let's go ahead and start solving. So I'm going to write this out. So p plus 2, p minus 1. Just going to rewrite this. Definitely be careful with your signs because it's very easy to drop a sign somewhere. So what are we going to do with our common denominator? Why do we have the LCD? Well, I'm going to multiply it to both sides of my fraction in hopes of canceling out the fractions because I don't want to work with them. Okay, and as I mentioned before, the step I'm looking for is to see that you have multiplied both sides by the denominator. You don't need to write out this step here where you actually show the multiplying. If you can cancel in your head, which I'm going to do now, you can go ahead and do that. So, when I multiply it out, the ones that cancel are the p plus 2 and the p minus 1, which means the only one left would be the p plus 1 and the 2. It's going to be 3 times the ones that are left, which is the 2 and the p plus 1. Minus. Now the next one, what would be left? Well, the p minus 1 will cancel with the p minus 1, and the p plus 1 will cancel with the p plus 1. So the only ones left are 2 and p plus 2. All right, and then our equal sign. And for the last one, what cancels? Well, the 2 will cancel with the 2, the p plus 2 will cancel with the p plus 2, and the p plus 1 will cancel with the p plus 1, so the only thing left is the p minus 1. Whew, okay, we're done. So let's go ahead and simplify. So we get 6 times p plus 1 minus 2 times p plus 2 equals 7 times p minus 1. So now let's go ahead and keep solving. To do that, let's go ahead and distribute in the values. Then we get 6p plus 6 minus 2p minus 4 equals 7p minus 7. Alright, combining like terms, we have the p and the p, and then the 6 and the negative 4. So we get 4p plus 2 equals 7p minus 7. I'll get the p's on the left side, or the right side actually, and then add 7 to both sides. So I have 7, 8, 9 equals 3p. Alright, and then all's done. Still dividing away. We get 3 equals p. Whew, what a ton of work, but we got there. P equals 3. Are we done? No, we need to check, because remember, we have variables in the denominator, which leaves room for the fact that our variable could cause a problem. So we need to check. So we'll go ahead and show the work for checking. And I'll use the factored form. So 3 over. And I'll go ahead and show plugging in my variable. So you have a +2, -1, plus 1, +2, plus 1. And already looking at it, I'm pretty positive my variable is going to work. So I'm going to plug in the 3. So then we have 3 over 5 times 2 minus 1 over 2 times 4 equals 7 over 2 times 5 times 4. So you know what? None of these turned out to be 0. So because none of them turned out to be 0, we're good. So because of that, we do have our solution. 3 equals P checks out. Awesome. So now we're going to go ahead and take a look at graphing rational functions. Okay, so these ones, they are a little more in-depth, so definitely take a look at the methods I have. Now, you don't need to follow the exact order that my steps are in, because I know some of you probably learned how to do these in your own classes in high school and so on. But the main thing is, the items I ask to see on these steps, I would like to see listed on your work for your exams. It doesn't have to be in this exact order. But if you don't remember how to graph these, then go ahead, feel free to follow the order I present. So the first thing we're going to do for graphing a rational function. Alright, first step, intercepts. So solve for x and y intercepts. And as always, state your intercepts as well as graph them. Then after that, we're going to find something called the vertical asymptote. Okay, the vertical asymptote, and I spelled that wrong, vertical. What is a vertical asymptote? Well, basically, it's a guideline. The vertical asymptote comes from the value that makes our denominator equal to 0. Basically, our graph goes along just fine until we hit that value, and then we have to create something called an asymptote because my graph does not exist there. It's undefined. So that's how we find the vertical asymptotes. And then, what do we have next? We have the horizontal asymptote. Which is similar to the vertical asymptote, but it comes from a slightly different method of finding it, which we do with long division. Okay, and the shorthand term for these, vertical asymptote, do capital VA, and it is always a line, so be careful, this is something at grade 4. So it's the line x equals and your number. And horizontal asymptotes, it's HA, y equals some number. Okay, so be careful. Definitely something I look for. And as usual with the intercepts, if you remember, x-intercept, you do your 0 and your y value, and y-intercept, you do your x value. Oops, wrong way around. You do x value 0 and then y. Sorry, I wrote the x-intercept a little wrong. Let's fix that. Okay, so once again, things I do grade 4. Alright, and then next 2. 4 is something interesting. It's called the cross-touch point. Cross-touch point. What is this talking about? It's talking about when my graph crosses or touches the horizontal asymptote. Now, my graph can cross the horizontal asymptote, but it cannot cross a vertical asymptote. And we'll see more of that when we're solving. And how do we find the cross-touch point? You set your function equal to your horizontal asymptote and solve. And lastly, you're going to graph. And use a table of values if needed to finish your graph. Alright, let's get started. Graph the following rational function using the 5-step method. So what was our first step? Intercepts. So for my x-intercept, I'll go ahead, set y to 0, and solve. Where's y? I only see g of x. Well, if you remember, g of x is the same thing as y. So go ahead and set that equal to 0, and solve. Now, I technically have two fractions equal to each other, so to solve, I can use cross multiplication. And I'm left with x plus 2 equals 0, because 0 times this is 0. Solving for x, I get x is equal to negative 2. So there's my x-intercept. I'll go ahead and plot that down. Negative 2, 0. Now let's find the y-intercept. How do we find that? Well, we set x to 0. And in my equation, so we have y equals 0 plus 2 over 2 times 0 plus 6. Then y equals 2 over 6, so y equals 1/3. A little hard to graph, we'll just go ahead and approximate that. 0 and 1/3. Okay, good, so we've done the first step. What's the next step? It's find the vertical asymptote. Okay, so these are the new steps, so go ahead and make sure to pay attention on these. So the vertical asymptote, basically, you just take your denominator and find the values that you can't have. It's just like finding the domain, which we did earlier. So we have 0 equals 2x plus 6, and we're solving to find out what value makes my denominator 0. Oops, that should be a 6. I don't know why I'm minus 3. Minus 6 from both sides. And then we'll go ahead and divide by 2. We get negative 3 equals x. So my vertical asymptote is at x equals negative 3. Once again, you have to use the line notation. So please make sure when you write your work down, your vertical asymptote is listed like that. Alright, let's go ahead and graph that in. I'll use yellow for the vertical asymptotes. So one thing to note, your asymptotes are not actually your graph. They are guidelines for your graph. And because they're guidelines, we use dotted lines when we graph them. Once again, vertical asymptotes aren't your actual graph, they're guidelines, so we use a dotted line, and then make sure to label them. Alright, what do we find next? Well, next step is horizontal asymptote. So how do we find the horizontal asymptote? We use long division. What are we dividing? This. We're going to use that division problem. It's already a division problem right there, so let's go ahead and do that. So we have x plus 2 being divided by 2x plus 6. And the question is, how many times can 2x go into x? No times. It doesn't work. The answer is 0. Well, this one was really short, so my horizontal asymptote is going to be y equals 0. Okay, once again, make sure to show your work like that. HA equals, and whatever it is it equals. So let's go ahead, graph in that horizontal asymptote. Alright, so y equals 0. We're on our way. What else do we need to do? So we've done our horizontal asymptotes. Let me go ahead and label it. There we go. The next thing we need to do is the cross-touch point. How do we find that? Well, the cross-touch point, if you recall, is when my graph passes or possibly touches the horizontal asymptote. And how do we find that? We're going to set our function equal to a horizontal asymptote and solve. So my function is x plus 2 divided by 2x plus 6, and we're going to set that equal to my horizontal asymptote, which is 0. and solve. So let's go ahead and do the cross multiplication. And we get 0 equals x plus 2 minus 2 from both sides, and we get that negative 2 equals x. Alright, so we do have a cross-touch point. And now careful, remember, it's a point, which means I need to answer as a point. Yeah, right. So what point is this? Well, my y value is 0, and my x value is negative 2. That was my y value right there. Alrighty, and there we go. And once again, this is how I'm going to look for the cross-touch point to be labeled. So please make sure to label as that. These are items I look for when grading. And my cross-touch point is exactly the same as my intercept. I'll go ahead and just label it CT. Okay, so now we need to actually graph. This is a slightly tricky part, but the main thing to note is your vertical asymptote splits your graph up into things we call branches. So we have two sides for the branch. We have this side and we have this side. Two sides for the branch. So we need to determine where my graph is going to be. And how do we do that? Well, usually we look for clues that we already have. But on this first side here, I don't have any points to go off of, so I need to find a point, which means I'm going to need to use a table of values. Alright, so let's go ahead and start the table of values. Just waiting for my pen to load. Alright. Actually, let me move it over a little. So I'm trying to determine where my branch is going to be on this side. It's either going to be above or below. How do I know it's going to be above or below? Well, if it was to cross through, it would have to pass my horizontal asymptote, which I know it can't, because the only place it crosses is right there. So it's either going to be in the top area or in the bottom. So I'll just pick a value on this side. Let's go ahead with -5, why not, and see where I end up. Alright, just waiting for my pen to load. Okay. So I'll pick -5 as my value and solve. So I have -5 plus 2 over 2 times -5 plus 6. And what's that going to be? That's going to be -3 over -10 plus 6, which is going to be -3 over -4. And that is going to be 3 over 4. Let me go ahead and box this off. So that point, -5, 3 over 4, is somewhere up here. Which means I know my graph is going to be on the top above the horizontal asymptote. And now something to remember. Each time you have a point, you have 4 options. It goes up or down or up or down. I know it's not going to be this option because it needs to be sucked along to my horizontal asymptote. One thing to know about horizontal asymptotes, they're kind of like a black hole. Your graph is going to be sucked towards them. It's slowly getting closer and closer. So with this dot on the left side that I'm graphing, I know it's supposed to approach the horizontal asymptote. So it's going to approach, but it's not going to touch, so be careful. And there we go. Now I have a question. My graph is either going to go up and approach the x-axis, or it's going to go down, cross the horizontal asymptote, and then continue on the axis. So which option seems correct? Well, we know we can only cross the horizontal axis once, and because of that, it must be the top one. The bottom one does not work. Let me go ahead and fix that up. Alright, so we finished that one branch side. Remember, our vertical axis cuts our graph into 2 different pieces. So we finished the right side. Now we have to do, we finished the left side, now we have to do the right. And with this point here, the cross-touch point, I already have the point, but I don't know if I should go down or if I should go up and follow the x-axis. And to figure that out, I need to find a point. So let's go ahead and do -2.5. Ooh, it's kind of hard to do, but let's go ahead and do that. I can't use 3 because that's on the axis. So that's going to be negative 0.5 over negative 5 plus 6, which is going to be, so we have a negative 0.5 over a positive value. So we know it's going to be a negative. You don't have to write the exact value. Once you know, you're good. So we know it's going to be a negative value down here, which means it's going to be the downward value. So I'm going to go ahead and erase this. I'll rewrite my intercept. Okay, so it's going down. The next thing we need to do is complete the other side of my dot. And since it crosses right here, and there's a point above, I know it's going to go up, but then what happens? Well, it still has to continue on the horizontal axis, and there we go. All right, so at the very end, it definitely takes a lot of sort of guess and check to determine where your points are. And this is just a sketch. It doesn't have to be perfect. Just make sure you get each of the branches and so on. Alrighty, and that is that for this one. Let's take a look at the next one. I believe there's one more example. Yes. Complete the graph using the 5-step method. Alright, so first things first, asymptotes. Not asymptotes, sorry, intercepts. So my x-intercept, set y to 0, which would be this. So we have 0 equals 3x squared minus 12x all over x squared minus 2x minus 3. And we can go ahead and put the 0 over 1 and cross multiply. And I'm left with 0 equals 3x squared minus 12x. Factoring, we get 0 equals x times 3x. Is x minus 4, which means, okay, zero factor property, set each one to 0. X equals 0 and x equals 4. So we have two intercepts. So we have x equals 0. And then x equals 4. All right, let's go ahead and plot those in. 0, 0, and 0, 4. And let's do the y-intercept. How do you find the y-intercept? Set x to 0. So that's going to be y equals 3 times 0 squared minus 12 times 0. Once again, I'm using this function right up here. All over 0 squared minus 2 times 0 minus 3. So y is going to equal, let's see, 0 over negative 3, which is just 0. So my y-intercept is at the origin, 0, 0, and I already have that plotted, so I'll stick with that. Okay, I did my intercepts. What's next? Vertical asymptote. And how do we find that? Well, the vertical asymptote is where my function is undefined. So that means I'm going to take my denominator and set it equal to 0 and figure out what's making it undefined. So x squared minus 2x minus 3. Okay, looks like we need to factor. So we'll go ahead and factor. And then zero factor property, set each one to 0 to solve. So add 3 to both sides. X equals 3, and what else? Minus 1 from both sides. X equals negative 1. So it looks like we have two vertical asymptotes this time. And now, so you can have multiple asymptotes that are vertical, but you will only end up having one horizontal asymptote. Okay, so let's go ahead and draw those in. 3 and negative 1. Once again, they're dotted lines because they're not actually on our graph. And then we'll go ahead and label them. X equals negative 1, x equals 3. Now, what do we need to find? The horizontal asymptote. And how do we find that? Well, we do the long division. So doing the long division, we have the 3x, let's see, we have 3x squared minus 12x divided by the x squared minus 2x minus 3. Let's go ahead and write that down. So x squared minus 2x minus 3 dividing into 3x squared minus 12x. Ooh, this time we can actually do the division. So x squared goes into 3x squared 3 times. And then, let's see what we have. So we have 3x squared, we distribute that in, minus 6x minus 9, cancel, and we're left with negative 6x plus 9. And we can just leave it right there. All we're interested in is the value on the top. And that is my horizontal asymptote, y equals 3. And let's go ahead and graph that in. All right, we're rolling along. What's the next step? Cross touch point. Okay, so how do we find the cross touch point? Well, we set our function, which in this case is f of x, equal to our horizontal asymptote. That's right. So let's go ahead and set them equal to each other. So f of x equal to horizontal asymptote, and f of x was 3x squared minus 12x all over x squared minus 2x minus 3 equal to our horizontal asymptote, which was 3. Alright, so let me go ahead and move this up a little bit. And then see if I can erase this. Okay, so let's cross multiply. So we can put the 3 over 1 to cross multiply. And then we end up with 3x squared minus 12x equals 3 times x squared minus 2x minus 3. We can distribute that 3, and we have 3x squared minus 12x equals 3x squared minus 6x minus 9. The 3x squareds cancel each other out, and let's move the 6x to the other side. Okay, we're really close to running out of room. So divide by 6, and we get x equals 3 over 2. So I do have a cross touch point at x equals 3 over 2. Once again, list your cross touch point. Alright, and then let's go ahead and graph that in at 3, 2. Oh, sorry, what was that? That was 3 over 2, 3. 3 over 2, 3. 3 over 2 is a little more than 1. Let's go ahead and do it right there. Alright, so we have done all of the main things. The next thing we need to do is to just fill in the graph with the bars. Now this time it's different than last time. Because we have 2 vertical asymptotes, we actually have created 1, 2, 3 different sections that need to have a graph. So let's go ahead and start on the left side as usual. I don't have any starting points, so because of that I have to use the table of values to create a starting point for myself. Let's just go ahead and pick -5. That's just, doesn't matter exactly what you pick as long as it's not on an asymptote. So let's go ahead, table of values, x, y, and I'll pick -5. So that'll be 3 times -5 squared minus 12 times -5 all over -5 squared minus 2 times -5 minus 3. Now because the test points on this takes a lot of time, feel free to use your calculator. You don't need to show me a lot of work on this, at least on this specific section for the testing points. So on the calculator it comes out to about 4.2-ish. So that means it's going to be above my horizontal asymptote. So I'll go ahead and once again, when you're using the table of values, it doesn't matter exactly being exact, just roughly in the estimate of where it should be. So -5, 4-ish, right there. Okay, so once again, each point we have has two options on the left side, up or down. Well, we know it has to follow the horizontal asymptote, so because of that, we know it's going to come down and approach our horizontal asymptote. Now the left side of our dot, once again, has two options. It can go up or down. However, if it was to go down, what would happen? We would have to, boop, cross the horizontal asymptote, which we know it doesn't do there. It only does at one point. So because of that, it must continue up and then slowly get pulled towards the vertical asymptote. There we go. Once again, it should look like it's going towards the vertical asymptote. If you graph it and your graph kind of pulls away from the asymptote, that is technically not correct, so I will be looking for that. Make sure it looks like it's approaching the asymptote. Alright, so we did one side. 2 more sides to go. For the middle one, do we have enough information to graph, or do we need to pick a test point? Well, I think we might have enough information to graph. If we look at the point 0, 0, we could go up or we could go down. However, if I was to go up, it would have to cross my asymptote there, which I know it doesn't. It only crosses right here. So because of that, we know it must go down. Alright, so it goes down on the left side of my dot. And then on the right side of my dot, it can either go up or down. But I know it's going to go up. Why? Because it has to cross my cross-touch point. But I have a question. It might cross my cross-touch point and then bounce back, or it might go up. Which one is it? I don't actually know. So because of that, I have to pick a test point. So let's go with the test point around here at 2. Alright, so plugging that in. Definitely a lot of work, which is why totally use your calculator. Just show that you picked a point and you tested it. Okay, let's see what I get. So it comes out to be 4, actually. I think it's exactly 4 according to my calculator. Alright, once again, don't matter too much on the values from your table of values, as long as you show that you tested a point. So since it comes out to be 4, which is up here, what option do I take? Well, I know it has to be the option going up. So let's go ahead and let me fix this up a little bit. So I have the 0, 0s. So it's going to continue, and it should kind of be a smoother line. Let me just erase that. Alright, so let's see. Waiting for my pen to load. So it should be a slightly smoother line, and then after this we only have one other branch to take a look at. So this is my cross-touch point. Alright, last branch. Hey, look, we have a point we can go off of. So with this point that we already have, we know we can go up or down. Which one do you think it is? Well, it can't be this one going up because we would have to cross the horizontal asymptote. So because it can't be that one, it must be the bottom one. So let's go ahead and do the bottom one. And then after that, we only have one other thing to check, the right side of that dot. Okay, so it either goes up or down, but it has to be pulled towards the asymptote, so it really only has one option. It's going to go ahead and just follow that asymptote. And that is it. We are done. So rational equations, graphing them can be a little challenging. So once again, please, if you have trouble with this, definitely come by my office hours. You know, it's the best time to ask questions. I can explain things. Please come by the office hours if you had any questions on this. Alrighty, and that is it.